Welcome to this Microwaves and RF Quick Chat. Today we'll be chatting about overcoming thermal challenges in modern electronic design. I'm David Moliniak, Senior Editor at Microwaves and RF, and today we're speaking with Melika Roshandell. Melika is Product Marketing Director at Cadence Design Systems. Melika, welcome and thanks for joining us. Tell us a little bit about your background to start us off.
Thank you, David, for having me today. So basically, I have a PhD in mechanical engineering, and I used to be a thermal engineer at Broadcom and then at Qualcomm. And then I joined Cadence, and now I'm the product manager for our product called Celsius.
Very good. Let's get into the topic a little bit. As developers of electronic products strive to meet the market demands for smaller and faster devices, the environment for thermal issues gets more and more challenging. These problems are widespread. It can be in the chip, it can be in the board, the package, or the whole system, and can impact not only the performance of the chip, but also the package and PCB performance because of resistive losses. And because these resistive losses are also temperature dependent, dynamic IR drop analysis is a must these days. So as electronic designs are shifting towards 2.5D and 3D ICs, thermal issues are exacerbated because of the heat that's generated by these multiple dies, and they're densely packed, and it all adds up in more temperature. So, understanding the thermal constraints in the early stages of designs helps engineers avoid their long design cycles and helps get to maximum performance in a short time frame. So Melika, tell us a little more, if you would, expand a little more on these thermal challenges in electronic design as things stand today.
Correct. You were actually correct about everything that you said. Yes, we started from only one chip and a package and a PCB. And if you remember, for example, the phones that we have when we had flip phone, they were so thick, and every millimeter of thickness, it will add half a watt of power that you can have. And as our phones are shrinking and shrinking, imagine our power envelope is also shrinking. So it's so important to address all these thermal issues in early design, especially for a chip, for example, because when you have a chip and you know exactly where your hotspot is, you can put your temperature sensor accurately, and then you can monitor that temperature sensor. For a chip, for example, what are the thermal optimization that they can have is reducing, for example, the frequency. And if they know exactly where the hotspot is, then they can have perfect mitigation algorithm for their chip. Then, you come to package and PCB, and it's so important to have the detailed model. We used to have softwares that they did not have the capacity to import the entire design for package or PCBs. But now it's a must, because, thermal is a global problem. So, and imagine if you have to simplify your model, you will lose a lot of accuracy. So you don't know where's your hotspots. So that's why it's important to have the capacity in the tools that you can import both package, PCBs, and chip, and do a global thermal analysis to see where are your hotspots and address those.
Okay. I know Cadence has a solution called the Celsius Thermal Solver. What is that? Tell us more about that and how it addresses these challenges.
Yes. Basically, Celsius Thermal Solver is a thermal solver that we designed for both electrical engineers and mechanical engineers. This is the beauty of Celsius. Celsius has two engines that has FEA and it has CFD. For FEA engine, for example, if an electrical engineer wants to do dynamic IR drop analysis, they can easily do it in our FEA. They do not need to simplify anything. They can import the whole design from Allegro or any other design tools. And that's very important when you want to do your dynamic IR drop analysis. Now, let's say that you want to optimize your thermal performance in an entire system, which has an enclosure, fan, then Celsius automatically generates a simplified model from the FEA, and you can bring it into the CFD. And we have, design models like fan, heat sinks that you can import and do your CFD analysis. Now, let's say that you want to bring it back with your boundary condition for your CFD into FEA to see, is that really helping your dynamic IR drop analysis? Celsius CFD can generate an accurate boundary condition, then you can import it back into your FEA and redo your analysis. This is the beauty of it. So not only that we designed this tool for electrical engineers, we also designed it for thermal engineers. So that reduces their model preparation time. Because if you talk to thermal engineers, one of their pain point is that they have to prepare the model, the input model, and it takes a lot of time. So now we made that automated from electrical engineers, automated to mechanical engineers.
Good. It's now, it's very important that tools like Celsius interoperate well with other tools in the flow. How does it work with the other tools in the Cadence portfolio to get a complete flow,
Exactly.
a complete picture?
Exactly. So one of the things that we have in Cadence is that since we have the design tools, we can definitely work with them and integrate with them. Right now, Celsius is integrated with the IC design tools like AWR, Innovis, and Virtuoso. And also we are integrated with package and PCB like Allegro and AWR. So that makes it a lot easier for input preparation. So, and we have an easy flow. So, people can do their package very easy, the package thermal analysis very easy, their PCB thermal analysis very easy. Also, we have a full flow with Voltus that you can do, fine grain chip level thermal analysis. You can either do performance analysis, or as I mentioned before, where to put your temperature sensor. So all those things is integrated because we have all these integration with the design tools.
Right. Yeah. There's so much interaction between all these various domains, and you end up playing whack-a-mole.
Right. That's right.
One last question. What do you see as the future of electronic design, and how will thermal challenges be addressed going forward?
Well, as you mentioned before, we are moving toward the 2D and 3D designs. So we can have multiple chip and, multiple stacked die or in one package. So all these things, as you mentioned, is definitely make the thermal analysis a lot more challenging. So one thing we have to do is to have a understanding in early design that, for example, what IP we want to put on what chip, then how that will impact the performance. So this is one of the important things. Or the other thing is that how big we want our package to be to help us with all these thermal issues that we might have in a chip. Or how big should our PCB be? Or where should we put our thermal vias? So all these analysis is important to do. And also it requires, as I mentioned before, a tool that can handle all those designs, because 3D ICs are really large designs, and you cannot divide it into little sections and do your analysis. You have to do the analysis as an entire design. So that's why it's important to have a tool that can address from your chip, package, PCB, all the way to your enclosures.
Very good. Well, Melika, thanks you so much for filling us in today on Celsius and how these trends are moving forward. And that'll be a wrap for today. Thank you for joining us, and thanks to our viewers for tuning in.
Thank you so much for your time.